Welcome back. So now we know that we can print a debug message whenever an effect is applied, but debug messages aren't enough for us, are they? We want to see something in the HUD or, do something more interesting. So let's close out of the editor and decide how we're going to handle this. We know that debug messages are out and showing stuff in the HUD is in. Now, to show stuff in the HUD, we have to think about our dependencies, right? Because our Aura ability system component knows nothing about our widget controller, but our widget controller is what broadcasts data to the widgets. And if we want to show something to the screen that's in the view domain, it needs to receive something from the middleman, the widget controller, which needs to receive something from the ability system component. So that means our ability system component should have a delegate. Now, what is our delegate going to broadcast? What information do we want? Well, a good way to identify things is with gameplay tags. If we have a gameplay tag that can be broadcast from whatever effect was applied, if that effect carries that tag, we can broadcast that to the widget controller, which can then broadcast it to the HUD. So we want to find out what gameplay tags the effect has. That's what we'd like to do, and then get those tags and broadcast those in a delegate. So we have a few things to do here. So how do we get any gameplay tags that an effect might have? Well, we have our effect spec, and if we just type effect spec dot, then we have lots of things at our disposal here. Well, if we scroll through these, we see that we have a bunch of getters related to tags. We have all asset tags, all granted tags. And remember, we can add those on the gameplay effect. We can add those granted tags. We've seen what happens when we do that. And we saw that the asset tags are not given to the actor that the effect is applied to. They're just kind of carried along with the effect. And because granted tags are only granted with duration-based effects, the asset tags is something that we could use to pass along some kind of tag that we'd want to know about once an effect is applied. So we can call get all asset tags to get those tags if there are any tags. Now, get all asset tags takes an fGameplay tag container. Remember, we don't store tags in a T array. We store them in an fGameplay tag container. This is more optimized than a T array for gameplay tags. It's just better all around. And that's what we're going to be using whenever we need a container of tags. Now, this takes one in by non-const reference, and it's going to fill it in with any tags that this effect has. So we need a gameplay tag container. So we're going to say fGameplay tag container, and we're going to sort of remember that all to our build file. We have gameplay tags. We added that to our private build file. Is in a specific module that we added to our build file. We have gameplay. Oh, remember, so get all asset tags takes tag container. We're going to pass ours in, and after this, tag container will have all those tags. Now, there may be one or more, and what I'd like to do is make a broadcast to our widget controller for every single tag that's in this container. That way, as we add any tags to our gameplay effects, we can get those tags and broadcast them and use those to display some kind of message to the screen. And we'll get to how to do that soon enough. We'll do it in a nice, efficient way. But for now, let's just loop through those tags. We're going to say for, and if I say auto tag in tag container, what does auto have the type of? Well, it's a gameplay tag. So we're going to say fGameplay tag, and we'll make it a reference so we don't copy the tag. And if we make it a reference, it's got to be a const reference. So now here, we can do anything we like with this tag. I'm just going to add a to-do here, and it's going to be to broadcast the tag to the widget controller. So that's the next thing we want to do. So when any effect is applied, we can get all asset tags associated with that effect that we've added in the gameplay effect blueprint and do anything we like with those. Now, I know we want to broadcast to the widget controller and that debug messages are lame and all that, but I'd like to use a debug message to show you that we can print the name of a tag. Tags have an internal f name that represents the tag, and we can say print messages to the screen. So I'm going to say gengine, add on screen debug message. For the key, I'm going to use -1. That way, newer messages don't replace older ones. Time to display, we'll do 8 seconds, 8.f. For color, we'll do f color blue, for lack of a better color. And I'll just make one here. I'm going to make a const f string ge. What is tag? It's called tag to string name. Let's return. So let's convert t card, convert in gameplay effects. I'm going to add and just see what we get printed. to the screen. Okay, so I'm going to add some tags to our effects. I'm going to go into the actor folder and into Crystal and into GE Crystal Heal and to the tag section here. Now we know that granted tags will actually grant the tag, right? But the gameplay effect asset tag, that's what we're retrieving in C++. That's because we're using get all asset tags and not get all granted tags. So these are all different containers. So since we're getting the asset tags, we're going to want to add our tag to the asset tags. So for GE Crystal Heal, I'm going to add the health tag. But this is a duration-based effect. I want to test out how this works with instant effects. In other words, potions. These apply instant effects. So I'm going to go to GE Potion Heal and go to my gameplay effect asset. Assets tag. Very important. Assets, not granted tags. And we're going to add the health tag to that one. And why not? Let's go to potion. Potion mana and add the mana tag to that one. So we have tags in the health crystal, the mana potion, and the health potion. Let's hit play and get a crystal, and look at that. GE tag attributes.vital. Health. Let's get a mana potion. Attributes vital.mana is now printed to the screen. And let's get a health potion. There's attributes.vital.health. So now we're getting these messages printed to the screen showing us that we've actually retrieved those tags. And the cool thing is that we can have multiple tags. If I go to my GE potion mana, let's just say I want to add another tag to it. Let's add max mana as well. And because this is a for loop looping through all the tags in the asset tags, let's get all asset tags. We'll get multiple messages if there are multiple tags. Now, GE potion mana has multiple tags. Let's just quickly test that out by picking up a single potion. And there we have two messages because we retrieved both tags in that gameplay tag container. So this works with multiple tags. Now this is great because now a given effect can have multiple tags. And if we loop through all of those and do something for each one, we can, say, print different messages to the screen, show different widgets, kick off any logic we like. We really have the power to do whatever we want here. So I'd like to broadcast the gameplay tag over to the widget controller, and that'll be our next step. So we'll do that next. For now, we'll go ahead and close out of the editor, save all, and make sure that if we're using source control, we make a commit, and I'll see you in the next video. All right, so now that we know when an effect is applied, and we have the ability to get the asset tags, for that effect, and we want those tags to be broadcast over to the widget controller, we need a delegate. So I'd like to make a delegate for broadcasting the asset tags. Let's go into Aura Ability System Component.h and make that delegate. Now, I don't plan on binding this from Blueprint. Our widgets aren't going to bind to this delegate. It's our widget controller that's going to bind to this delegate. So what I'm going to do is declare a multicast delegate that's not dynamic, and it's going to have one param. And that param is going to be the asset tag, or if we like, the gameplay tag container with all the asset tags. It's really up to us. Now I'm going to call this f effect asset tags. And our single parameter, again, it could be a gameplay tag or it could be a gameplay tag container. I'm going to use gameplay tag container. So we're going to have a gameplay tag container. We'll go ahead and make it a const f gameplay tag container reference. And as we've seen with declare multicast delegate, we don't put the name of this parameter. We don't say comma followed by tag container or anything like that. But sometimes what I've seen, and this can be a little helpful, is making a comment here, an inline comment, to sort of hint about what this is. So we could say asset tags. And so even though that this comment does nothing to the code, it tells us when we look at it that that's what this tag container is. It's the asset tags. Now, our ability system component needs this delegate. It needs to be able to broadcast the delegate, and our widget controller needs to be able to bind to it. So we need to make this public. So in the public section, we're going to have our f effect asset tags, and we're going to call this effect asset tags, and we're going to broadcast it. Now, what we can do, if we like, is we can broadcast it here, broadcast it. Now, what we can do, if we like, is we can broadcast it here in effect. Effect applied, because we know this gets called and we have our asset tags. We have the tag container. So all we need to do here is just say effect asset tags dot broadcast and pass in tag container, just like that. And then any class who binds to our effect asset tags delegate will receive a tag container filled with the asset tags. Pretty simple. So really quickly, to test this out, what we can do is we can go into our overlay widget controller and bind to effect asset tags if we like. So let's do it. We'll go into UI, widget controller, and overlay widget controller. But you know what? I'm going to go into the CPP file directly. So overlay widget controller.cpp. And here in bind callbacks to dependencies, I'd like to get our ability system component. And we know that this is a ability system component, but we want the Aura ability system component. So I'm going to cast to u Aura ability system component, our ability system component. And using this, I'm going to get that f effect asset tags called effect asset tags. Now we know if we're going to bind to this delegate that we need a callback function, right? Well, not necessarily. If we hit dot, we have a lot of options here. And one of them is to add a lambda. Now a lambda is an anonymous function. It doesn't have a name. It doesn't get declared anywhere. It's not a member function. It's just a function. And add lambda lets us define right here in the parentheses whatever functionality we want called in response to the delegate broadcast. A lambda looks like this. I'm going to hit enter a couple times and just put it right here. In fact, I'll go ahead and put my semicolon there. And right here, this is inside the parentheses to add lambda. Add lambda requires a lambda. We're going to make a lambda here. So first we put square brackets, then we put parentheses, and then we put curly brackets. Okay, so this is the signature for a lambda. But if we bind anything to a delegate, it needs that signature. It needs the signature of a function that can take an f gameplay tag container. Well, this lambda has parentheses. That's where the input parameter list goes. So we can put a const f gameplay tag container reference, and we can call this asset tags. Doesn't matter what we call it. So now we have a lambda, which is an anonymous function. And when the broadcast happens for this delegate, this lambda will be called. And it has an input parameter called asset tags. It will receive that from the delegate. And what happens when it gets called? Whatever we put in the body here in our curly brackets. I'm going to put them on a new line to make this a little easier to read. And we can define what happens here. So what do we want to happen, right? Because we've just now bound a lambda to affect asset tags on the ability system component. Well, why don't we just print a debug message and make sure it works? So back here in Aura ability system component, I think we're done with this debug message, but what I'd like to do is copy it, or rather Control X to cut it. So now our ability system component is not doing any debug messages. It's just broadcasting a delegate. But now our widget controller has a lambda that will fire off in response to that delegate. Well, I'm going to Control V right here, and we can paste this code in where we can loop through the tag container. Now, here inside the lambda, it's going to receive asset tags. That's the tag container. So that's what we have to loop through here. So we have a for loop looping through all the tags in the asset tags container. And we don't need this comment. And, well, we know what these two lines do. They take each tag in asset tags and add an on-screen debug message, basically the same thing as we were doing before. So the difference here now is that the ability system component will broadcast this delegate in response to having any effect applied to it, and it's going to send that tag container. And then it's the widget controller that's going to parse the data. It's going to loop through the tag container and print it all to the screen. So if we can run this and it works, then that's actually really cool, right? Because this means we don't have to go and declare callback functions for all the delegates that we want to bind to, right? This makes things a little bit simpler. I mean, look at all these callbacks we had to make for all of these delegates. What if we could just use lambdas for all those? Well, let's make sure this works first, okay? Let's go ahead and hit debug and see if we can get some messages printed to the screen. Okay, so we're back. I'm going to go ahead and let it open up my game. gameplay effects. I'm going to go ahead and let it open up my gameplay effects just to make sure. Our Potion Mana gameplay effect has 2 tags in its asset tags. Potion Heal has 1 and Crystal Heal has 1. So let's press play and get a crystal, and look at that. It's working. Our lambdas are working. How about that? This is great. Now, if you're skeptical, you can place a breakpoint here. So I got a breakpoint. I'm going to press play and pick up the potion. And look, the breakpoint works even in a lambda. So a lambda is one of those tools in C++ that we have at our disposal that allows us to kind of avoid having to create a bunch of member functions, especially for things that are simple, right? If we're going to bind a callback to a delegate and it's pretty simple, there's really no point in creating a whole callback function for it. A lambda is cleaner sometimes. And it's also kind of fancy, right? It's kind of cool. So now that we know how to do that, we just have one more tool in our tool belt. And if you already knew about lambdas, maybe you've been using this already, then you already have this tool in your toolbox, and I think that's great that you've been taking advantage of it. So excellent job. We're now one step closer to our goal. We have those asset tags here in our widget controller, overlay widget controller. The next step is to get them to the widgets themselves. So we can do that next. In the meantime, I'm going to do the widget taking advantage of it. So excellent job. We're now one step closer to our goal. We have those asset tags here in our widget controller, overlay widget controller. The next step is to get them to the widgets themselves. So we can do that next. Welcome back. So now we have the ability to know when we've had an effect applied to us, such as when picking up one of our pickups, and we know which gameplay tags those pickups have. In the case of our mana potion, we have 2 gameplay tags in that gameplay effect. Specifically, we're accessing the asset tags in the gameplay effect. These are tags that are not given to the actor that the gameplay effect is applied to. They're just carried along in the gameplay effect, and we're retrieving them, and we're sending them over to our widget controller. So back in Writer, we can see right here where we're taking the ability system component member on our overlay widget controller, we're casting that to an Aura ability system component, and we're getting the effect asset tags delegate that we created, and we're adding a lambda to it. So we created this lambda, which is welcome back. So now we have the ability to know when we've had an effect applied to us, such as when picking up one of our pickups, and we know which gameplay tags those pickups have. In the case of our mana potion, we have 2 gameplay tags in that gameplay effect. Specifically, we're actions that are not in the gameplay effect, and where so back in Writer, our opponent, anonymous function that has its own body here and its own input parameter container. And we're looping through that and printing a gameplay animation that's using a game kind of that we can ask by game that we can quickly for going to controller. I'm going to need to give this a name. So we're going to say struct, and I'm going to call it EF tables for, so we'll use now this data tag messages to display that and edit, and we'll go ahead once fine for gameplay to display the user in the form of a widget we use F text. Now in this to this that we can in the form of, and it's used at the top here. So there it is, and this will be the message. Now our message, maybe we like, and really they harvest more data, such as there going to be a U texture if row structure. So I'm going to go ahead and close it down. The data table UI data can come here, and I'm going to right click and make a new data table. So I'll go to miscellaneous and choose data table, and for the row structure structure, I have to choose my and launch the editor from here. So we get a fresh compile. Okay, so back in the editor, now I'm going to make a data table. And for now, we'll just use the editor from here, folder into UI. And here in the UI folder, I'm going to make a new folder called data. And that way, any data tables or perhaps data assets, anything related to data can come here. And I'm going to right click and make a new data table. So I'll go to miscellaneous and choose data table. And for the row structure, I have to choose my structure that I created called FUI widget row. And the F is gone here in the editor. So it's just UI widget row. I'm going to select it, click OK. And call this DT for data table. And this can be our message widget data. So we're going to say message widget data. And we'll open it up. And here we can add a new row. And we can give it a name. It can be associated with a tag. We can choose a tag here. We can set the message here. We can set a widget and an image, all that stuff. It's all there. So I'm going to save that. I'm not going to fill in any data. But what we do need are some message tags for any messages. And right now we have 4 types of pickups. So we can make some message gameplay tags. And we can do that by going into project settings. So in project settings, we can go to gameplay tags. And we can have tags that we add here. We can even make a new data table for those tags if we wanted to do that. I leave it up to you. But I'd like a new type of gameplay tag. I'm going to add new gameplay tag here. And this will be message.healthpotion. So I'll have a message. Health potion, and that's going to add that here. And I'd like to add more messages. Know when our widget controller has received WBP overlay here. So, okay, let our widget has received WBP can bind to delegates on the widget controller that we may wish to broadcast up here into the Blueprint realm. And if we go back into our widget controller C++ code, overlay widget controller.cpp, right here is where we're binding our Lambda to whenever we receive a tag container that's associated with a given effect. Tags. Then we can have a new data table that has those assets in UI/data, right here, DT message data table. I'd like to have a variable of this type on my widget controller. controller. And that way, we can always look up from this table to get any assets that we want to broadcast to the widgets. So that's the last thing I'm going to do in this video is close out of the editor, and we're going to add a variable to our widget controller, our overlay widget controller class for the data table. So we'll make this a protected variable. We'll go down to the protected section, and above our function callbacks, I'm going to have my data table, TObjectPointer. So I'm going to make edit anywhere to have a default to expose it. The cat will have a play tags from events, cast data from that data table, the widget data table for our widget controller. So I'm going to go to Blueprints UI, widget controller, and open my overlay widget controller. There's my variable. I can expand the dropdown, and we have DT message widget. Data. I'm going to set that as the message widget data table. And now we can access that, and we can perform the lookup in C++. So we'll be doing that next. I'll go ahead and close project settings, and I'll see you in the next video. In Blueprints UI, I'm going to set it to Health Crystal. Now, when we look up in C++. So we'll be doing that next. I'll go ahead and close project settings, and I'll Welcome back. Now, let's go back to our data table we just created in Blueprints, UI, Data. Here it is. And we added one row, but we didn't fill anything out. But we did add 4 new gameplay tags to our project. So for this first row, I'm going to set my message tag. We have our messages, and I'm going to set it to Health Crystal. Now, when we look up rows to find a specific row in a data table, we can look them up by name. So for my row name, I'm going to have the same name as my message tag. So I'm going to double click on new row here and call this message.healthcrystal. And we're going to look this up by name. Now, this method is a little bit error prone because you can have typos here, but as long as you type it correctly, you should be fine. For this reason, I often like to use data assets instead of data tables. And we'll be using data assets throughout the course as well. But I think it's good to know how to use both data assets and data tables, and we're going to use a data table for this particular application. So we have a message tag. We can also have a message, and for my health crystal, I'm going to have the message picked up health crystal. Now, we don't have a message widget just yet. We still need to make one of those, but we can choose an image. And in our project, if we search for T_health, we have a T health crystal. And if I browse to it, it's in this UI pickups. So we're going to want a list of these rows as the this one, a and a health potion. The others picked up health crystal, picked up a health potion. Let's just say A in all of them, picked up a health crystal, a mana potion, picked up a mana crystal, picked up a mana potion. potion. That looks good. Okay, so there's data in all four of the rows, and the row name is the same as the tag. So we'll be looking things up by name. So now that we have four rows, this is great. I'd like to be able to look these up and to each have blueprints folder, potion first, and open GE potion heal. Now we added to the gameplay effect assets tags. That's what we're sending over to the widget controller, but we just added some tags that we had just because we had them. I'm going to clear all, and if I compile, you'll see that removes it completely. And I'll add to the added tags. We're going to go message, and this is GE potion heal, so I'm going to choose message health potion. GE, the add all, we just assets tab and open GE, and then we have crystal. Crystal and potion. We'll go into potion first and open GE potion heal. Now we added to the gameplay effect. We just add pile. You'll see tags. I'm going to clear all potion, compile crystal heal, and combine heal. So I'm going to the old tag. Looks like I have crystals. Those. So and we'll see that we get those message tags. Tags because we're receiving. So we're done in the editor for now. I'm going to save all in row in our message widget data table. Now I'm only concerned right now with the overlay widget controller. So I'm going to right click on the header file, close other tabs, and then open the CPP with Alt O. Or Control KO. And I'm back here in the CPP file. Now we're still just in bind callbacks to dependencies right here in our Lambda. All we're doing is receiving the gameplay tag container that contains our asset tags for any effect that has just been applied, and we're printing a message to the screen. That's all we're doing. But now I'd like to make a lookup in our widget data table. So how are we going to do that? Well, I'd like to be able to find the data table row that corresponds to the gameplay tag, right? This tag here, as we're looping through all the tags in this gameplay tag container called asset tags. I'd like to be able to take a data table and a gameplay tag and return the row. So to do that, I'd like a function, but I'd like this function to be sort of versatile. I'd like it to be able to return any sort In other words, we want a delegate that can send through an FUI widget. Everything's looking good on that. in the, and I'm back here, and we're printing a message to the screen. That's all we're doing. But now I'd like to make a lookup in our widget data table. So how are we going to do that? Well, I'd like to be able to find the data table row that corresponds to the gameplay tag, right? This tag here, as we're looping through all the tags in this gameplay tag container called asset tags. I'd like to be able to take a data table and a gameplay tag and return the row. So to do that, I'd like a function, but I'd like this function to be sort of versatile. I'd like it to be able to return any sort of row, any sort of data table row by just taking in a generic data table and a gameplay tag. So let's make that function. I'll go back to the header file, and in the protected section, I'm going to make a really nice generic function. And the return type is going to be a data table row, but I'd like this function to be able to return any type of data table row. So I'm going to have the return type be t star. In other words, a pointer to type t. How can I do that? Well, this is going to be a template. So template function, we use template with angle brackets, and we say type name followed by t, and t is going to be our type parameter. In other words, this function can be called with any type, and this function will be called get data table row by tag. And I'd like to be able to pass in a u data table. That'll be by pointer. We'll call this data table. I'd like to pass in a const f gameplay tag reference called tag. So we have a template function here, and it's going to take in a data table and a tag, find the row, and return that row. So let's generate a definition, and if I let writer do it for me, it's going to make this definition right here inside the header file. Which is pretty common for template functions. In fact, some compilers won't let you put it in the CPP file at all. Some compilers are smart enough to look in there, but we're going to keep it right here. And Visual Studio should do the same. And when you have the function definition, notice we still have template type name T above it. That's required for template functions. And this function is going to be designed to find a data table and return the row, no matter what the row type is, right? So really, this is a more useful function than we should have in just the widget controller class. This is the kind of thing that's working. So when we get to the point in this course where we make our own function libraries, more versatile, we have a table, find row to type. Well, the types function context value name is make the return identical with text and turns us. It uses so we can store this in a local. And once we have the pointer, turn row null, same turn. Oh, simple function. But this is a bit of an ugly line, so I think get data table row by tag is better, and we're going to use that. So here in our Lambda, what we can do is we can call get data table row by tag, and because this is a template function, we have to specify the type. We have to specify T, which is oops, so do it. This anonymous something like again call a function, call a member anonymous function doesn't know about the overlay widget control to the project. Therefore, then that thing that now we can capture variables. We can capture if we want to this object that right. So notice as soon as I put this is simply this object that we're in. So a pointer to this is simply the keyword this, right? So notice as soon as I put this, we have to capture things by reference. We can capture something like a gameplay tag container. As we have here. And we can do things like call a function on GEngine because that's global. But now we're trying to call a member function that exists on the overlay widget controller. And this anonymous function doesn't know about the overlay widget controller. It only knows about what we're passing in and perhaps anything global to the project like this function. It doesn't know about get data table row by tag. That's where these square brackets come in. The square brackets are for captures. If we want to access a member variable from something, then that thing, that class that has the member variable, must be captured within the Lambda. Now we can capture variables, we can capture things by reference, we can capture things by pointer, and if we want to be able to access get data table row by tag, we have to capture this object that we're in. So a pointer to this is simply the keyword this, right? So notice as soon as I put this in the square brackets, we're now capturing this, the object that we're in, and that object has get data table row by tag. It's now defined within the Lambda scope, within the body of the Lambda. So if you want to call a member function in a Lambda, you have to capture that object of the class that that function belongs to. So now that we're capturing it, we can call get data table row by tag. And that's great. Now we have the row. We can even store this in a local variable FUI widget row. Pointer to is we want to send this row up because we want to delete, and we're going to do that next. So great job, and I'll see you soon. Welcome back. So now we're successfully finding the data table row associated with any given tag. We now would like to broadcast this up to widgets that can bind to some kind of delegate and receive that row, and then show something in the HUD. Using assets from that data table row. So we're going to want some kind of delegate. So let's go back to overlay widget controller.h. I'm going to move it over to the right here. We're going to make a delegate up here at the top. And we're going to use one delegate for all messages because we can just broadcast a row. That's all we need. The row has all the information to identify that specific bundle of data. It has a gameplay tag, it has the message, all of this stuff is in the row itself. So we could just use one row to rule them all. So I'd like to make a dynamic multicast delegate one param just like these. Only we're going to call this delegate signature f message widget row signature. And it's going to broadcast a value of type FUI widget row. So we'll put that there and we'll just call it row. Now FUI widget row is undefined right here. And we're not going to use a pointer. We're just going to use an FUI widget row, which means we need to define the struct before we define the delegate. So we can just cut the entire struct definition with Control X and move it up to above everything. I'm just going to put it just below the includes there. And now it's defined. Now, as soon as we move it up here, well, now we're using some types in the struct that are not defined, and move it up to above everything. I'm just going to put it just below the includes there. And now it's defined. Now, as soon as we move it up here, well, now we're using some types in the struct that are not defined. Defined yet. And these ones we can forward declare. So we're using or user widget. That's really the only one. We can forward declare this. I'm going to go ahead and forward declare it just right here. And now if I compile this, then I get a successful compile. So now we're all good on our types. So now that we have this signature, let's make a member variable of this type right here, just below the others. So I'm going to call this message widget row delegate. Or we could just call it message widget row. Doesn't matter. And I'm going to make it blueprint assign. So I'll put that U property there. And for the category, let's give it gas with the pipe symbol and then messages. And now we can broadcast this delegate. So we're going to do that. Now, I I know you're probably thinking, if we just have one delegate for all messages, why can't we just have one delegate for all attributes? And the answer is you actually could. We could just have an F on attribute change signature, as they're all floats anyway. So we'll probably have some refactoring to do that in the near future. But for the task at hand, we just want to broadcast a UI widget row. So now that we have this delegate, let's go back into our Lambda. And just after getting that row, we can take our message widget row delegate, we can call broadcast, and we can broadcast the row. Now we know that this is a pointer, so we're going to have to dereference the pointer. So we'll just say star row. And dereference it, just like that. Now, you might be thinking, isn't there a problem with this system? What if asset tags has a gameplay tag that is not a message tag, right? What if it's some other tag we choose to use for something else for the gameplay effect? We don't want to restrict our asset tags container to just message tags, right? So how do we enforce, or rather restrict this functionality to only when we have a message tag? Well, tags are super useful, and we can do things like that. The gameplay tag has some functions. Let's type fgameplay tag :, and search for match. And notice we have a bunch of functions that start with match, such as matches tag. Now, this is not a static function, but I just wrote this so that I can right-click on matches tag and go to its definition. So go to declaration or usages, just tag, and go to its definition. So go to declaration or usages, and matches tag is not a static function, but I just wrote this so that I can right-click on matches tag and go to its definition. So go to declaration, right-click on matches tag, and go to its definition. So go to declaration or usages. Here it is. We can see what it does. But let's Control-K-O and find it here in the header file. It's in gameplay tag container. And what we do is we call this function on a gameplay tag, passing in another gameplay tag. So it says, determine if this tag matches tag to check. That's what we pass in. Expanding our parent tags. And it says a.1.matches tag a will return true. a.matches tag a.1 will return false. And it says if tag to check is not valid, it will always return false. So if this explanation seems a little confusing, let's copy this line and come back to the widget controller. And we'll make a little comment here and paste that in. So a.1 matches tag a will return true. What does that mean? Well, let's take our tag, use dot, and we'll call matches tag, okay? Now we want to match against the message tag. And if a tag exists in our project, it exists in one of our config files, then we can get the tag with the static function f gameplay tag : request gameplay tag, which requires an f name. So we're going to say f name, and then we say the tag we want. We want message. So this returns a gameplay tag. We're going to store it. We're going to say f gameplay tag message tag, and request gameplay tag has a bool called error if not found, automatically set to true. So if we call this with a tag that does not exist already in our project, we can't see it in project settings, we'll get an error. But we can use message, even though we have message.healthpotion, message.manapotion. Well, message is considered a tag as well. It's the top of that little hierarchy. So we can call tag.matches tag and pass in a tag. We're going to pass in message tag. And now we have something more concrete for this explanation. So let's make this a little bit less confusing, shall we? Let's take a hypothetical example. Now we know that tag in asset tags could be one of those message tags in our project. So let's take the example where tag is equal to one of them. We'll say, for example, say that tag is message.healthpotion. So here in this comment, we're going to replace A with message and 1 with health potion. So here A is message, and over here A is for this, and message. However, message just tags matches a tag. Then we belong comment there. Screen debug message. I'm going to go ahead and remove. Now this returns a bool, and it will be true if tag is and will message table a message as its root const. Okay, so now we have a broadcast, and all we need to do is bind to this del test it out the data table row. So that's going to be it. So I'd like you to make BP overlay and bind an event that is to do this, widget, pause the, and here in the UI overlay, I know now bind nodes up and out of the way and controller, but trust it. These nodes, but before and cat this to a variable. I'm going to call it BP overlay right there. And after setting the widget controllers for BP widget, and see I have that, add a pin to this delegate gets broadcast. Here in WBP overlay, we have our event called in response, but it receives this. This, a UI widget row structure, and we can drag off, use this. We have delegate gets and bring it out. I'm going to control and looking that up over. So in widget control, we're going to bind up and out of the way, organize things. So sequence here to organize things. So I'm going to move these nodes up and out of the way. Give them a reroute node there. And the next thing we're going to do is we're going to bind to the delegates on the widget controller. But remember, our widget controller is just a U object, so we need to cast it. So in fact, I'd like to do that first. So then one can be these nodes, but before I do that, I'm just going to cast my widget controller. Here it is. I'm going to duplicate this and cast to BP overlay widget controller, and I'm going to promote this to a variable. So hooking that up here. Here and promoting it to a variable. I'm going to call it BP overlay widget controller. So now we have that there. And after setting the widget controllers for the health globe and the mana globe, now we can take our BP overlay widget controller. I can drag off of it and I can type message widget and see I have my message widget row delegate. I can assign to that. I'm going to choose that. Add a pin to the sequence and bring it out. And check this out. As soon as this delegate gets broadcast, here in WBP overlay, we have our event called in response, but it receives this, a UI widget row structure. And we can drag off, and we can even break this, and we have access to all sorts of cool stuff here. Now, I'd like to just make sure this is working by using a print string node, and I'm going to take my message and just stick it in there. So we can see the message that corresponds to the gameplay tag in the effect that was applied. So, saving all, I'm going to pick up some things and see what we get printed to the screen. Picked up a health crystal. That looks great. Let's get a mana potion. Look at that. Picked up a mana potion. Picked up a health potion. Picked up a mana crystal. So we're getting the message from the data table. In fact, we're getting the message from the data table. In fact, we're getting the entire data table row corresponding to whatever gameplay tag was there inside that gameplay effect. And the cool thing is we're looping through the gameplay tag container. So there could be multiple message tags if we really wanted to have multiple. And I'm not going to show you that example. I'm sure you understand that you could just add to the asset tags for a gameplay effect. And because we're looping through, we would be broadcasting the delegate multiple times. So now that we know that our system is working, we know that we have access to the gameplay tag, the message, the widget, which we're not really setting the widget yet. It's just a widget class, actually, because that's a t-sub class of. But we haven't set that in the data table for any of our tags, but we will. And then we also have the image as well. So we have a lot of information now that we can use to display any kind of message we want to the screen. So we're going to do that in the videos to come. So great job, and I'll see you soon. Welcome back. So we've done quite a few interesting things so far. In our overlay, WBP overlay, we are receiving a broadcast from the widget controller, and it's broadcasting this row structure that contains a few pieces of information, one of which is a message widget. Now we'd like to show that widget on the screen, which means we need a widget to show, right? So let's make that widget and add it to the screen and see what happens. So right here in WBP overlay, I'm going to make a new folder called subwidgets. Or just subwidget, and we'll have all the widgets that our overlay should have. So we'll make a new widget blueprint, user interface widget blueprint. We're going to choose Aura user widget, select that, and this will be WBP, and this is going to be our message widget. So I'm going to call this effect message. As when we get in, so I'm going to cut in the interface widget blueprints. We're going to choose Aura user widget blueprint. We'll have all the widgets that our overlay should have. So we'll make a new widget blueprint, user interface widget blueprints. We're going to choose Aura user widget. So I'm going to call this effect message, as when we get an effect applied to us, we want to show this message. Now, this message is going to have some text, but also, remember, our row structure has an image as well. So if we want, we can display the image. We can do all kinds of things. So what I'd like to add is a horizontal box. That will allow me to put things from left to right as I drag them in. And I'm going to come up here where it says fill screen, and I'm going to set this to custom. So that way I can customize the size of this. Now for my horizontal box, I'd like an image and some text. So pretty simple. I'm going to drag the image in, and because it's a horizontal box, things come in from left to right. So that's just going to work out nicely. So I'm going to rename the horizontal box to horizontal box underscore root, and the image, I'm going to call image underscore icon. and I'd like some text in here. So I'm going to get a text block there. And just so we can see what it kind of looks like with an actual message, I'm going to change the text to say, picked up a health potion. So that's kind of what it's going to look like. And I can adjust the size. And I can also set the image as well. I'm going to rename the text to text_message and select the icon and open up the brush to give it a default. I'm going to go to T potion red. I'm going to find that image as well. And I can adjust the size. And I can also set the image as well. I'm going to rename the text to text_message and select the icon and open up the brush. I can also set the kind of what it's going to look like, and I can adjust the self potion. So that's kind of what it's going to look like, and I can adjust the size. And I can also set the image as well. I'm going to rename the text to text_message and select the icon and open up the brush to give it a default. I'm going to go to T potion red. I'm going to find that. And here in the graph, and it is going to find to give it a default. I'm going to go to T potion red. I'm going to find that. And here in the graph in the designer tab, as I resize, notice that the designer find that. And here in the graph in the designer tab, as I resize here in the graph in the designer tab, as I resize, notice that the image resizes along with it, but we can set the image size right here in the brush, and that's what's going to determine what it will look like on the screen. For example, I can set X and Y in the image size for the brush to to 75, and then even though it's changing when I adjust the size up and down, it's going to have 75 by 75 on the screen. Now I'm going to select the text, and for the vertical alignment, I'm going to choose center. so it's in the middle there. And for the font family, this project starts off with some fonts. And for the vertical alignment, I'm going to choose center. And for the vertical alignment, I'm going to choose center, so it's in the middle there. And for the font family, this project starts off with some fonts. I'm going to use the Amaranth font. I'm going to give it an outline. So in the outline settings, I'm going to set outline size to 1. We'll give it an outline. So in the outline settings, I'm going to set outline size to 1. And I'd like to see what this looks like on the screen. So I'm going to compile and save it. And go into my overlay and search for effect message and bring in an effect message. So I'm going to drag one in, and I can drag and stretch it out, but I don't want to do that. So after I've already ruined it by stretching it out, I'm going to go ahead and delete it and just bring in another one because it'll come in with the right size. So pressing play, I can see that this is what the message looks like. So that doesn't look too bad. The text is a little close to the icon, but we can fix that. I can search for a spacer. Spacers are good for placing space between widgets, and I can select the spacer, and for the size, I can click and drag the X to give it a little bit of space there. I can click and drag the X to give it a little bit of space there between the two, and that looks better. So I now have a message, but as soon as we add one of these to the viewport, or right as we're adding it, I would like to be able to set the image and the text. And I'm also going to make this quite a great deal longer, just in case we need a longer message. So I'd like to have my image icon and my text message to both be variables. So I'm going to come up here and check is variable, like so. And so I'm going to come up here and check is variable, like so. And I'm going to go into the graph, and I'm going to make a function to set these. I don't want to use event preconstruct. That's like the construction script. That would be if I wanted to design one of these, but it's not really for changing things at runtime. For that, we need to use a function. I'm going to make a new function, and I'm going to call this set brush and text. Actually, I'm going to call it set image and text. As we we know that our row structure, if we go back image and text, as we know that our row structure, if we go back and look at it, it has an image that's a textured 2D, and then we have our message. So that's a text. So I'm going to have set image and text, take those two as inputs. So I'm going to add an input. This will be a texture 2D. I'm going to choose object reference and call this image. And I'm going to add another input of type text and call it text. And then I can take my image icon and my text message and set them. So I'm first going to take my image icon. And I'd like to set the image. And to do that, I have to set the brush. So I'm going to call set brush. And for in brush, I'm going to drag off and make a slate brush and expand it. So we now see all the parameters here. And the image is way down here at the bottom. I'm going to hook that in. We're going to leave it at draw as image. With no tiling, no mirror. But for the image size, this can be something that we may want to have different values for depending on the message. Now, something like this would be great if all of our icons were the same size. But this might be something we may want to override. So we may wish to have a parameter that we can set for the image size. So what I'd like to do is make a vector 2D for our image size. So I'm going to add a variable. And this will be a vector 2D. I'm going to have to search for it. So here it is, vector 2D. And I'm going to call this image size. And I'm going to drag it in and hook it in for the image size. So that's going to set our image. And then we can set our text as well. So I'm going to take my text message. And from this widget, I'm going to call set text and use the function set text. That's the one we need to use. And I'll hook text in right here. And to make this neater, I'm going to actually call set text first. I think it just looks better. Okay, so we have image size, and if we needed a different image size, we could always subclass this widget and set that. We go ahead and compile and give this a default of 75 by 75. And compile and save, and now we have a widget. And our widget has a function, set image and text, that we can use to set the image and text. So all that's left is to draw this to the screen. And here in the overlay, we'd like to create one of these widgets and add it to the viewport. But we'd like to get the widget from our widget row, which means our data table should have these widgets. Now, for now, we can just use the same effect message for each of those rows. So I'm going to go into Blueprints, UI, Data, and open up my message widget data. And for each of these, I'm going to set the message widget to WBP effect message. And if I browse to it and have it selected here in the outliner, then I can go to the next row, and for its message widget, I can hit the left arrow, and it'll put that same widget in, so I can go to the next one and do the arrow, and the next. One and do the arrow. So we have the arrow for all of them. And now we have that widget, and we can construct the widget. So what we can do is we can right click and use create widget and hook in that class for the class. And for the owning player, it has to be a player controller. We can simply use the static function getPlayerController. That's the gameplay statics function. We'll just use that just because it needs a player controller. So we'll create the widget, and this is an Aura user widget. So if we want to call the function that we call, and this is an Aura user widget. So if we want to call the function that we called set image and text, then we have to do one of two things. One, we can cast, or two, we can change the type of widget in the data table to effect message, and then we wouldn't have to cast. For now, I'm just going to cast it. I'm going to cast a WBP effect message. And as the effect message, I'm going to call set image and text. And for the image, we're going to drag in the image from our data table. And for the text, we're going to drag in the message, like so. Now, all this is going to do is create the widget. We have to add it to the viewport if we want to see it. So as WBP effect message, I'm going to call add to viewport. And then we should see it in the viewport. I'll go ahead and reroute the nodes here. And it's not going to go away. It's just going to be added to the viewport and stay there. Nodes there, that's fine though. WBP overlay, save that. And with that, we can press play and we can pick up a potion. Okay, so there's our widget. And as we can see, it's sized pretty badly. And as we pick up more, we're just adding more to the viewport. So we need to fix that. We can't have it just stretch like that. So what I'd like to do is take my horizontal box, right click on it, and select wrap with and choose overlay. And select wrap with and choose overlay. And that way we have everything wrapped up in an overlay. And now if I press play, now it's wrapped up in an overlay. And that way we have everything wrapped up in an overlay. And now if I press play, now at least it's the right size, right? Because that horizontal box is kind of stretchy. It's going to stretch to fill the volume that it's in, but with an overlay wrapping everything, at least it looks the correct size. Now, it's up there at the top left of the screen, so we could fix that by setting its position. So we can take our Aura user widget, drag off of it, and type set position in viewport. And for this, we can choose where we want it in the viewport. So I'm going to go ahead and call that, and we'll make some room here. And for the position, I'd like to do this based on the size of the viewport. So I'm going to call get viewport size. This returns a vector2d, and I'm going to multiply this vector2d by 0.5. So I'm going to right click on this pin, convert it to a single precision float, and multiply by 0.5. And hook that into the position. So we're taking the viewport size, X and Y, cutting them both in half, which should give us the center of the viewport, and passing that in. So let's see. See where that shows up, and it shows up right in the center there. So I'm okay with that. And again, we're not removing it, so as we pick up more and more things, we're just adding more and more of those widgets to the center of the screen, but at least we can see it for now. We can take care of getting rid of it. That's definitely something we're going to want to do next, but at least we're seeing it on the screen, so that's a good start. So the next things to do are, obviously, we want to get rid of this widget. We only want to see it for a second. Maybe we can animate it and fade it out and then destroy it. So that's something we want to do, and we'll do that next. But for now, we have a nice widget that shows on the screen, and we can pick up different pickups. And depending on the asset tags in the gameplay effect that the pickup is applying to us, we can use that tag to look up from our data table the widget, the icon, and the message to use. And that's really nice. So great job. We'll clean this up in the next video and make it look better and get rid of widgets after a certain amount of time. So All right, welcome back. Now we have these widgets. We're showing them on the screen when we pick something up. But they just stay there. They don't go away. And I kind of like to animate them, make them look a little bit nicer. So we can go into our WBP effect message and make an animation. And we can play that animation. And we have a perfect place to play it, our function where we set the image and the text. Now, I do want the message to be sort of required, but I really don't care about the image. If the image is null, I'm okay with that. So I think I'd like to be able to call this with an empty or a null image and just show the text without the image if we want to do that. So what I'll do is take the image input and just check is valid. And if it is valid, then we'll set the brush. If it's not valid, we won't. Now for the animation though, I'm I'm going to come back into the Designer tab, and we can animate this any way we want, really. In fact, we could even animate the text separately from the image if that's something we want to do. So let's make our animation. I'm going to go to Animations, click plus Animation, and call this Message Animation. And select that. And with our message animation selected, I'm going to add a track. And for the track, I'm going to choose my text message. Now, be careful. We can choose basically any widget, and the boxes and everything else, they're all widgets. We want to animate this text message. And I'm going to add a track for it, and the track is going to be for its transform. So I'd like to take and the track is text message. And I'm going to add a track for it, and the track is going to be for its transform. So I'd like to take transform, and really we just have to set some keys and decide how we want this to look. So if we're going to be picking up multiple pickups very quickly, then I think it might be a good idea to move the text up, make it slow down a little bit, and then fade it off to the side. That's kind of what I want it to look like. So first, I'm going to go up by probably 0.25 seconds or so. We can always experiment with this. And I'm going to expand translation and drag the Y down, because going up is the negative Y direction. And I'm going to go up to about here, perhaps. And that's going to give us a key. And let's just see what that looks like. I'm going to press the space bar, and that brings it up to about there. If you want it faster, just move that key back a bit, and I can hold Control and scroll in and right-click to drag around. If I want finer control, I can put it to 0.1 seconds. See what this looks like. So that's pretty fast. And after 0.1 seconds, I can start to move it to the side. I'm going to take my X and move it over to here. That'll give me a key for that. And let's see what that looks like. It's a little bit stiff. So right about here, I'm going to take my X and put it back to 0. So that way it doesn't start going to the left until it reaches up there. So let's see how that looks. Still kind of stiff. Start going to the left until it reaches X and put it back to 0. So that way it doesn't start going to the left until it reaches up there. So let's see how that looks. So that way it doesn't start going to the left until it reaches up there. So let's see how that looks. Still kind of stiff. So I can select my X keyframes, these two, right click on them, and they're already cubic auto, but I'd like to take a look at their graph. So I'm going to click right, and they're already frames, these two, right click on them. And they're already cubic auto, but I'd like to take a look at their graph. So I'm going to click right here on the graph, expand the transform, select the X, and here's what it looks like. I'd like this to transition a little slower. So I'm going to take this keyframe here and just angle it down like this. And I'm going to move this window off here. I'd like form, select the graph. So I'm going to click right here on the graph. Already cubic auto, but I'd like to take a look at their graph. And they're already cubic auto, but I'd like to take a look at their graph. So I'm going to click right here on the graph, expand the transform, select the X, and here's what it looks like. I'd like this to transition a little slower, so I'm going to take this keyframe here and just angle it down like this. And I'm going to move this window off the screen, and I'm going to play the animation, see what it looks like. Okay, so that looks a little bit different. I'm going to click the no looping, turn it into loop playback range so I can loop this. So it's looking better, I think. Range so I can loop. That looks a little bit different. I'm going to play it down like this. And I'm going to move this window off the screen. And I'm going to play the animation, see what it looks like. Okay, so that looks a little bit different. I'm going to click the no looping, turn it into loop playback range so I can loop this. So it's looking better, I think. I like how the X is behaving. Let's alter the Y a little bit. So I'm going to click on Y, and here's what it looks like. And remember, negative is going up in the screen. So let's see how this looks. I'm actually not too mad at it, but I'm going to play with the shape of the curve here. In fact, I can let it overshoot a little bit. Let's see how that looks. I kind of like that overshoot. It looks like it bounces a little. We can even make it overshoot more. We just have to be careful that we don't make it too jarring, right? So that looks pretty cool. I like it. And if we want some damping, we can have damping as well. We can right click, we can add a key. We have to do it on one of these vertical lines, of course. But if we add a key, then we can get a sort of bit of oscillation going here. That's kind of like damping. I can add another key here, like so. I can move this up a little bit, move this down a little. But we should always be looking at what it looks like. If that's a little bit too jarring, we can always just remove those keys instead. Just have this one. And if we don't even like that, we can change that as well. So that looks okay. We'll see how we feel about that on the screen when we play it. So why don't we do that now? I'm going to go ahead and close this little window, compile and save, and let's go into the graph. Now we call this message animation. So back here in the graph, we're going to right click, type message animation. We're going to get that. And we're going to play this. So I'm going to use animation. So back here in the graph, we're going to right click, type, going to use play animation and hook this right up. But set brush here only happens if the image is valid. So we also need the is not valid hooked up as well. So we have to be careful about that. So now that we're playing the animation, we know that our animation takes about maybe half a second. So after half a second, I would like to destroy the widget, which means I'm going to want a custom event, as we can't have a delay right here inside of a function. But I can make a custom event, and I can call this destroy delay. And from here, I can use a delay node with 0.5 seconds or so. And I can use remove from parent. And we can just call destroy delay right here after we play the animation. Now, we do want it to fade away as well. I don't want it to just go over to here and then disappear. That's what it's going to look like. But let's just try it out anyway. I'm going to save all and press play and grab a potion. And there it goes. It's a little fast, I think. So we can adjust that, but it's working. And to prove that this is being destroyed, we can go into our event graph and use event destruct. This gets called when it's destroyed. And we can print a string that says hello. This gets called when it's destroyed. And we can print a string that says hello. And there's that hello. So we know that it's being destroyed. So there's no memory leaks or anything like that. Okay, well, our animation clearly needs some work. So for one, it's too fast. I'd like to make it a little slower. So I'm going to take the last key and bring it out to probably out there. We see that our X is going to the left there. So we're going to want to make some adjustments to the graph. I'm going to bring these keys out. And then these keys out to make some adjustments to the graph. I'm going to bring these keys out. And then I'm going to go to the graph view and open up translation. Here's the X. I don't want it to go down. That's going to the left. So what I'll do is just adjust this a bit. Bit like that. It's going to the translation to go to the graph view and open up translation. Here's the X. I don't want it to go down. That's going to the left. So what I'll do is just adjust this a bit like that. And here, here's the Y. It's going up and then back down. It's a little extreme. So let's go ahead and calm this curve down. A little bit. That looks a little better. Let's see how it looks here in the viewport. That's better. And remember, our destroy delay is 0.5 seconds. So we can come back in here. We can make it say 1. Try it out. That's better. And we see that it gets destroyed right there. But that's fine. We can fade it out because we know that our animation is 0.85 seconds. So really, we can make the delay 0.85 before we destroy it, but we can also fade it out by that time. So let's go to our animation, and for our text message, we're going to add a new track, and this will be for render opacity. And for this, we're going to start it off at 1, and we're going to fade it down. to, for this, we're going to new track, and this will be for render opacity. And for this, a new track, and this will be for render opacity. And for this, we're going to start it off at 1, and we're going to fade it down to 0. So we'll put it at 0 here. And we just have to make sure that it starts at 1 and stays at 1 for a while. So let's go ahead and press play. And there we go. It fades out. At 1. And just have to make sure that it starts at 1 and stays at 1 for a while. So let's go ahead and press play. Stay here. And for this, we're going to start it off at 1, and we're going to fade it down to 0. So we'll put it at 0 here. So we'll put it at 0 here. And we're going to add a new track, and this will be for render opacity. And for this, we're going to start it off at 1, and we're going to fade it down to 0. So we'll put it at 0 here. And we just have to make sure that it starts at 1 and stays at 1 for a while. So let's go ahead and press play. And there we go. It fades out. Still a little fast, I think. This kind of thing takes a little tweaking, but I'm going to control mouse wheel to zoom out, and let's put it all the way up to perhaps a second 0.25, because we really want our players to have the opportunity to read it. And going back into the graph view, I just want to make sure it doesn't go to the left at all. So making that look good. Here's our render opacity, and we can also play with the curve here as well. That's looking pretty good, I think, as well. That's looking pretty good. I think that's as much as I'd like to play with it. And for the image, we can add animate this as well. And I'd like it to be on the same animation as our text. To be on, that's looking pretty good. I think that's looking pretty good. I think that's as much as I'd like to play with it. And for the image, pretty good. Play with the curve here, or render opaque. So making that left at all. So making that look good. Here's our render opacity, and we can also play with the curve here as well. Also, so making that look good. Here's our render opacity, and we can also play with the curve here. Render opacity, and we can also play with the curve. curve here as well. For the image, we can animate this. And I'd like it to be on the same animation as our text. That way we only have to play one animation. So I'm going to collapse that for the text message. We're going to add a new track for image icon. And for image icon, we'll add a track for the transform. And we'll mess with the translation a bit. So what would we like to do? Well, let's see. If I click on text message and expand it, I see that up to about here, 0.25 seconds, is where our text goes up. So for the image at 0.25 seconds, I want to take my Y and move it to about here. And then we'll make our, it might look a little way. I'm going to have it go to the right to fade out a lot faster. So I'm going to do our here. Do 5. I'm going to move fast. How we do this doesn't really matter that much. Translation, we'll go to the Y. It's going to go. I'm going to full screen it and give it. Getting that bounce, messing with this for now, because really you could tweak these things all day. Was not good. Oh, now it's bouncing. All right, I'm just going to take a couple seconds, bounce as well. Key here and a key here, making it bounce just a little bit. And so just adding a key here and a key here, and making it bounce just a little bit. Okay, and day for this video. And it's data-driven with our data types and dimension. We'll continue in the next video. I'll see you soon. Welcome to your next quest. In this quest, I'd like you to replace the callbacks in our overlay widget controller with lambdas. So we have some callbacks for when our attributes change, and we're binding those to delegates on the ability system component, but I'd like you to actually get rid of those callbacks and instead welcome to your next quest. In this quest, I'd like you to replace the callbacks in our overlay widget controller with lambdas. So we have some callbacks for when our attributes change, and we're binding those to delegates on the ability system component, but I'd like you to actually get rid of those callbacks and instead use lambdas inside of which you're going to make those delegate broadcasts to the widgets. So pause the video and conquer this challenge now. Okay, so for this quest, we're going to replace some callbacks in the overlay widget controller. I don't really need gameplay tag container, so I'm going to close those files. And here we have our callbacks, health change, max health change, and so on. And all these functions are doing is broadcasting some values with our delegates. And by the way, I'm noticing something right here. My on max health changed is an on health changed signature, not an on max health changed signature. It's something from copy pasting, I think. So I'm going to take my on max health changed signature and just replace that there. Now the reason it still worked is because this is a separate variable than this, and they're both just delegates that can broadcast a float. So really, there's no reason that we can't use the same delegate for all of our attributes and just create a new variable of that same type for each one. So maybe we'll refactor that here as well, but is the correct. That's a function attribute change. Add UObject, we're going to call add lambda instead. And the lambda goes right here inside of the parentheses. So I'm going to put those each on new lines. So we can put the lambda right here in between. Now it's going to have square brackets, it's going to have parentheses, and it's going to have a body. And in the parentheses, that's where we put a new line so we can see the scope of this. This lambda's body. Broadcast, get the red square into the two you could. So I'm going to hit Control Z a few times until it gets back to how it was. And so we're going to go through the getter for the attribute. We want get mana attribute, and we want to change. Okay, so we've just reduced the amount of code quite a bit. And again, we could make this 4 lines of code right here if we wanted to. It doesn't have to take up this much space, but I prefer this way for a lot of things. 4 delegates that are essentially identical. The only thing that's all functionally identical grow in number. So really, we don't need to declare a new signature. And we'll call this float new value. And then we can just have one of these. Each of these can all be the F on attribute changed signature. We can change them all to this. And we can come back here and delete the broadcasting a float. That's all we care about our delegate being able to do. And for some reason, I think I've deleted a semicolon down here. So I'm going to fix that. And with that, I should make sure this all compiles because we've made quite a few changes here. So compiling. And you make this our widget declarations, and we have less functions. In fact, we have, let's hit the debug button and test it out. All right, so I'm going to press play, and pressing play is a good way to find out if we have some errors in the blueprints. I'm going to open all errored blueprints, and my message log gives me links to where those errors are. I'm going to click on the one for Health Globe, and really it's just because our delegate has changed. All I need to do is right click and refresh nodes and make sure that those connections aren't broken. And I have another one down here on max health changed. We can refresh the nodes here and hook that up. compile here. Actually, I see the 2 errors. Refresh nodes. I'm going to save all and then test and pick up mana. We're getting mana. Looks good. Let's pick up health. We're getting health. Looks great. And everything works. Excellent. welcome to your next quest. Now, for this one, we're going to make a ghost globe, and I'd like this to be a challenge that you take on. So your goal here is to make a globe that is a ghost of your actual globe. And make sure this works for all globes, and look into the asset folders for materials that you can use for these. Now, what is a ghost globe? A ghost globe is a progress globe, just like the red globe for health or the blue globe for mana, but it's behind the regular globe and it trails behind in a smooth manner. So as the health globe changes, goes up or down, the ghost globe trails behind it, kind of interpolates to it. So this is a more challenging quest for you. And I'd like you to give it a try and see if you can get it on your own. But if you're starting to get a little too frustrated, you can't get things to work, then go ahead and watch the rest of this video and follow along with me, and we'll do it together. But try to stretch those brain muscles just a little and see if you can figure out a good way to do it. And if you end up doing it completely different from me, that's okay. This is a learning exercise, and it's designed to get you to try to implement mechanics on your own, to see if you can do this on your own. How to do. Not succeeding 100% is totally okay. It's normal and part of the learning process. Not to think that you're not smart enough, ace the challenge, no problem, without trying. These challenges, especially the ones that I'm pointing out like this, are designed to challenge you. They're designed to be hard. So really, I just want you to give it a try, give it your best shot, and don't spend all day on it. Don't spend too long. If you find yourself getting stuck to the point where you don't know what to do next, then go ahead and watch the rest of the video and follow along with me. So give this a try, see if you can figure out a way to do it on your own. If not, unpause the video, we'll do it together. So go ahead and pause now and conquer your quest. Okay, so we know what we want to see whenever our health globe or mana globes change. We want to see a sort of ghost globe following or trailing behind in a smooth manner as those changes occur. So since I want this to work for both health and mana globes, this means I should take advantage of inheritance. So I'm going to go into my Blueprints UI progress bar folder and go into the base class, WBP Globe Progress Bar. I'm going to get that open first and foremost. Now, I'm going to take a look at the assets folder and see what materials and material instances I have. I'm going to go into UI, into globes, and see what we've got here. Now, you might have taken the hint that in my ghost health globe is meant to do exactly what we want. We want this sort of ghost, and really, it doesn't matter that a line. Now, you might not. Parent has a progress. You'll see it can use material instances dynamically at runtime. You can use that too. Hop. All you have to do. Anyways, we have another way. So be within this and select that ghost. This is our ghost name, a parent base widget. Now I'm going to add another progress bar. So searching for progress bar. I'm going to add it right here on overlay root and select that progress bar, and right away I'm going to rename this to progress bar underscore ghost. This is our ghost progress bar. And if I set horizontal and vertical alignment to fill, then it fills the widget, and you'll see that it's in front. It's covering everything else. And for now, that's fine. I'm definitely going to put it behind everything else. But for now, while I'm working with it, that's okay. Now, for the background image, I definitely want that to be transparent. So I'm going to take that tint color and bring the alpha all that to be transparent. So I'm going to take that tint color and bring the alpha all the way down to 0. And as I raise the percent, I see it's going from left to right, and it's blue. So I'm going to fix both of those problems now. I'm going to set fill color and opacity by dragging the saturation down to white so there's no tint there. And I'm going to set the bar fill type to bottom to top. So as we change the percent, we see that it's going from bottom to top. Perfect. Now we need that globe background image. So let's give it a default. I'm going to select and search for mi underscore ghost and choose ghost. Ghost health globe or ghost mana globe, really doesn't matter. And remember, we need to draw as image if we want this to look like it should. We want it to look like that round material instance that it is. And it looks like I used background image, so I'm going to actually reset that. I don't need that. I want the fill image, right? So I'm going to set this to draw as image and change the fused like that round like it should. We want it to look like that round material instance that it is. And it looks like I used background image, so I'm going to actually reset that. I don't need that. I want the fill image, right? So I'm going to set this to draw as image and change this to mi ghost, one of those ghost globes, and it looks good. And by the way, the reason we can do this is because if we go back to mi health globe, for example, and browse to the parent material, which is not a material instance, and we double click that, this is just by the way, you'll see that its material domain is set to user interface. So that's why we can use it in a widget and it looks like it looks here, because this material was made with user interface in mind. It was made specifically for being used in a material interface. And perhaps at some point I'll show you how to make this material if I get enough requests, say in the Discord. Now, back to our widget. we have our ghost globe, right? And so that's step one. Now we are going to want it to be in the back. And also, if you really want to experiment, you can drag the tint down if you want it to be darker or something like that. And of course, you can also go back into the material itself. We have a lot of parameters here too. Now I'm going to drag progress bar ghost all the way up so that it's behind everything else. And that way, it'll do its job as the ghost globe, just trailing behind everything. And one kind of cool thing you could do is if you wanted to see that ghost globe behind our blue or red globe, whichever one it is, you could take that progress bar globe and open the tint and drag its alpha down a bit so you can kind of see the ghost globe behind it. That's one thing you can do if you wanted to do that. And just to kind of see that it's working, that's one thing, so you can kind of see the ghost globe behind it. Drag its alpha down at progress bar globe and open the tint and drag its alpha down a bit so you can kind of see the ghost globe behind it. That's one thing you can do if you wanted to do that. And just to kind of see that it's working as it should, I'm going to do that a little bit. I'll put the alpha at 0.9. Now we have our progress bar ghost. I'm going to, of course, check is variable there. And it looks like my progress bar globe did not take that change. I'm going to set that there. Okay, so progress bar ghost is here in our base widget, and we want to set this so that it follows our regular globe whenever it changes, right? So we need to think about how we're going to make that happen. Well, I'd like to make use of interpolation. And for interpolation, we typically interp on a framely basis. Every single frame, we're interping towards some value. And because we don't have too many of these progress globes in our UI, we can do this for both our health and mana, and we won't experience any performance decrease. So I'm okay with using tick functionality for our progress globe. And what I basically like to do is constantly every frame be interpolating this ghost progress globes percent down or up to our regular progress globes percent. So essentially, we're going to want some kind of target to set. So I'm going to go back to my graph tab. And we know that we have our set progress bar percent. Every time we set that, we're setting the percent value, and the percent is what our ghost globe is going to want to interpolate to. But I'd like a new variable, a new float that we can interpolate this to so it's designated for the ghost globe. In other words, a ghost percent target for interpolation. So I'm going to make a new float. I'm going to click add variable, and I'm going to call this ghost percent target. And I'm going to change it to a float. And every time we set our percent, I'm going to set our ghost percent target, but I may want to have a sort of delay, right? Maybe our regular globe changes and then we wait a second or two, and then we have that percent target set. So if we want some kind of delay, then every time we call set progress bar percent, then we'll want to use a delay node. Now, we can't use a delay in a function, but what we can do is we can make a custom event that we can call every time set percent is called. So here in the event graph, we can write right click and make a custom event and call this globe percent set. And every time globe percent is set, we can then set our ghost percent target. So that means that globe percent set should have an input. Let's click plus input, make it a float, and we'll call this percent. And then here in set progress bar percent, we can call our custom event globe percent set. We can call this passing in the percent. So I'll just reroute the node down here. Like so. There we go. So every time we set the percent, we're going to call this custom event. And then once we set the custom event, we can set ghost percent target, but we can use a delay node here. So that way we can have the delay. And the delay can be a parameter, or we can hard code it. I'm just going to promote it to a variable and call this ghost delay. I'll compile and give it a default value of 0.5. We'll give it a 0.5 second delay. And I'm going to put these in a category of their own. So for category, I'm going to call these ghost globe properties. So my ghost delay is in it, and I'm going to set my ghost percent target to ghost globe. Properties as well. And compiling here, it looks like I get a compiler error, so I'm going to go ahead and refresh the node. There we go. I'm going to set my ghost percent target to ghost globe properties as well. And compiling here, it looks like I'll compile and give it a default value of 0.5. Okay? I'm just going to promote it to a variable and call this ghost delay. I'll compile and give it a default value of 0.5. We'll give it a 0.5 second delay. And I'm going to put these in a category of their own. So for category, I'm going to call these ghost globe properties. So my ghost delay is in it, and I'm going to set my ghost percent target to ghost globe properties as well. And compiling here, it looks like I get a compiler error. So I'm going to go ahead and refresh the node. There we go. So I'm going to, and compiling here, and I'm going to take my percent and set ghost globe percent to that. So every time we set the percent, then ghost globe percent will also be set. Let's actually organize this a little bit like so. There we go. That's looking better. Okay, so really all we're doing is every time we set the percent, we're setting the ghost percent target, but we're waiting 0.5 seconds before we do that. Now, another thing is, what if we want our ghost globe material to be swapped out? Well, we can swap that out just like we've created parameters for the other brushes. We have an update globe image here, which really should be update globe brush, shouldn't it? I'm going to go ahead and rename that while I'm noticing that, because everything else is consistent. So this should be update globe brush. But we can have an update ghost globe brush as well. Instead of having a progress bar fill image, we can have a ghost progress bar fill image. So I'm going to add a new variable under globe properties here, a new slate brush, and call this ghost progress bar fill image. And I'm just going to call it ghost progress bar brush. And this is going to be a slate brush. And our progress bar fill image is actually going to be progress bar fill brush. I'm going to rename that too. Actually, and our progress bar fill image is actually going to be progress bar fill brush. I'm going to rename that. Too. And this can go into ghost globe properties. Let's give it that category. And we'll compile and give it a default value for the brush image. And I'm going to give it mi ghost health globe. Compile that. And we'll make a function just like update globe brush. We'll have an update ghost globe brush. So I'm going to make a new function, update ghost globe brush. And just like update globe brush, we're going to make a slate brush with 0 opacity. That'll be for the background image. we'll use the Ghost Progress Bar Fill Brush, and we'll use the Ghost Progress Bar Globe and set style. So what I'm going to do is just copy all this and go into the Ghost version, paste them all in. Hook it all up. But instead of Progress Bar Globe, we're going to use the Ghost version, Progress Bar Ghost. So we'll switch that out, and instead of Progress Bar Fill Brush, we're going to use Ghost Progress Bar Brush. And of course, this is called Ghost Progress Bar Brush, and the other one is Progress Bar Fill Brush. Just to be consistent, I'm going to call the other one Progress Bar Brush, just so we have consistent names there. And now we have Update Ghost Glow Brush, which we should call right here. With all our other update functions, which, by the way, we could collapse all these to a single function if we wanted to do that. But anyway, we have Ghost % set, and all this does is set Ghost % target, but we're going to want to interpolate our Ghost % to this every frame with some kind of interp speed. So we have a function to set our progress bar %, right? And what we should do is every frame set our Ghost progress bar %. So let's look at set progress bar %. All it does is set %, right? And also call our new custom event glow % set, but we're going to want to set Ghost progress bar % function. Let's add that function. And we're going to say set Ghost progress bar %. And this will just call set % on the Ghost progress bar. Let's get our progress bar Ghost out. Call set %. And just like set progress bar %, which takes in a float, we can add a float input here. So we'll add a new input of type float called the %. I'm going to compile right away, and then we'll use % to set the % for our Ghost progress bar. Now we want to interpolate. So Ghost, and then we'll use % to set the percent for our ghost progress bar. Now we want to interpolate. So let's just use event tick. And what we have is we have our ghost progress globe. Let's get that out. Progress bar ghost. And what we're going to do is relates floats. So we need to know the current value of the ghost progress bar percent. If we drag off of the ghost progress bar and type percent, we can get percent. And we can hook that in. That's the current value every frame. Now we know that we have a target, and that's a float called, if I can find my ghost properties, it's called ghost percent target. And that's going to be for the target there. Now we have delta time because we're using event tick, so we're going to hook in delta time. And now we need an interp speed. Now this can be experimented with. I'm just going to try a value of 1. In fact, I'm going to make this a parameter, promote to variable, and call this ghost interp speed. I can go ahead and put this into the category of ghost globe properties. Compile and set it to a default value of 1, which it is. And so after we've interpolated here, what we can do is we can set our ghost globe percent. So we can get that new function, set ghost progress bar percent. We can hook in the return value from the finterp2 and simply call this here. Now, before we test this out, we're doing something in event tick and the globe progress bar, and that means we need to make sure that this tick is being called in child classes. That means our widget blueprint and health globe widget blueprint and our mana globe. So we need to right click on event tick and WBP print and our this. That means our widget blueprint and health globe and child classes and a globe. Add a call to parent function. So if you were sort of stuck on this part, this might be the parent function. Click on event tick and WBP health globe and add a call to parent. So right click on event tick and WBP health globe and add a call to parent function. So if you were sort of stuck on this part, this might have been something that you needed to do. And we'll do the same thing for mana. We'll add a call to the parent function here. Make sure to hook up all the nodes. We're health globe and add. So we need to right click on event tick and WBP health globe and add a call to parent and something that you needed to do. And we'll do the same thing. Thing for mana. We'll add a call to the parent function here. Make sure to hook up all the nodes. And that way the child classes will get their parent version of tick, and that's very important so that we get that interpolation going. So let's go back and press play, and we can see that even though the health globe and the ghost globe don't start off at the same values, that ghost globe and the ghost press play important so that we get that interpolations. We'll get their parent to the parent needed to do. And we'll do the same thing for mana. We'll add a call to the parent and press play, and we can see that same values, and of course to a value of 1, so we can get a nice, you can see with my globe, update globe, that has its own tint. That here for progress bar, wanted say bar brush, and that has its own tint. Here we're update brush in update globe brush. We're updating with progress bar brush, and that has its own tint here. So if we really want progress to a value of 1, A determines 1, 2, I can see interpolation going, even though the health globe back, and that's very important so that we get that interpolation going. So let's go back and press play, and we can see that even though the health globe and the ghost globe don't, and we can see that going. So let's go back and press play, and we can see that even though, so let's go back and press play, and we can see that even even though the health ghost globe is interpolating, don't start on too long it takes. Before that happens, we can set that to a value of 1. We don't see any transparent the brush in progress bar brush and then on the alpha. So now we should the globe set this alpha and in that case see that the ghost globe is trailing behind, and you can recolor like 0.3. It's not a %, and this will just call set % on the ghost progress bar. Let's get our progress bar ghost out. Call set %. And just like set progress bar %, which takes in a float, we can add a float. And just like set all set % on the ghost bar %, say progress bar %. Ghost and look into the asset folders. A ghost red globe, regular globe, and it trails behind in a smooth globe. Trails behind globe changes, goes up or down behind in a smooth manner. So as the health globe changes, goes up or down. So, and I'd like to get the rest of this. Those brain muscle and exercise to see if you says I want your not just as assigned to see if you do it to smooth manner as the health and mana go into my materials and material. I'm going to take a look at the tab. I'm going to take in the head exactly what we. There's a ghost man. It's a globe. Bring it up % of an A. So if your globe. Right here on overlaying this to progress bar underscore ghost. This is our else. See, it's a default use member. One of those with user so that it's behind the ghost alpha down a bit, so you can kind of if it progress. Okay. Extremely basis. Interpolating this to my new variable, a new float that we can interpolate this to, so it's designated new variable. Globe is going to want a float that we can a ghost % target for interpolation. So I'm going to make a new float ghost, and every time I may changes, and then we sort of delay or two. So our % but set % should like we're going to call this custom event target can be and call this value of 0.5. I'm going to call these ghost at my ghost % target to ghost globe properties as well. Refresh the node, and I'm going to set the %. So really all we're doing target, but we're waiting 0.5 seconds before we do that. Material to be swapped out. Well, we can globe material to be swapped out. Well, we can swap globe material to be swapped out. Well, we can swap that out just like we've created parameters for the other brushes. We have an update globe image here, which really should be update globe because everything else is consistent. So this should be update globe brush. having a here bar, ghost progress bar, and our that too. Category, and for the brush health globe, compile that. And brush, ghost, update globe. Brush. We're going to make a slate brush with 0 opacity. That'll be for the background image. We'll use the ghost progress bar fill and set stop and paste them all in. Ghost version. So we'll progress bar brush. And of course, this is called ghost progress bar brush, and the other one is progress bar fill brush. Just to be consistent, I'm going to call the other one progress. Have update with all our other updates. Functions. But anyway, we have ghost percent set, and all this does is set ghost percent target, but we're going to want to interpolate our ghost percent. So we should do set progress, call our new custom event globe percent set, but we're going to want and we're going to say ghost out. Let's call set percent on it. We can add a float input here. So we'll add a new input of type float called percent. I'm going to compile right away our ghost product. Use event tick to set. Want to interpolate. And what we have is bar interpolate. And what we're going to do is interpolate. I'd like to use. We need to know the ghost progress bar every frame. Now we know we can find my ghost properties. It's called ghost percent target, and that's going to be for the target there. Now we have delta time because we're using lead. Now this can be experimented with parameter, promote the variable category of ghost globe property. And so after we've interpolated here, what we can do is we can set our ghost globe percent. Set ghost progress bar interp 2, and simply call this here. Now, and that means means our widget blueprint tick is being called in child classes. That means so we need to right click on. So if you were sort of stuck on this part, this might have been something that you need to function here, and that way important so that we get that interpolation. Even though the health globe and the ghost globe don't start off at the that and going. So let's go back and press play, and we can see that even though the health globe and the is interpolating down to before once the globe up this bar 0.9 behind the globe set this alpha to, but in that so that which step into the fire so we can Welcome to your next quest. Now, for this one, we're going to make a ghost globe. And I'd like this to be a challenge globe that globes is now progana, but it's behind as the health it kind of and along with people. If you and do facing of totally really enough, you know that I'm pointing. So don't point where you don't belong with on your own. Now, okay, globes change. We want to see a sort of those changes occur. This means I should take
每次都想抓头很倔强，但是天每次的去就是投降。每次都想抓头很倔强，但是天每次的去就是投降。每次都想抓头很倔强，但是天每次的去就是。
Les couilles, c'est dangereux sa mère. Je vois que t'es. Bah ouais, bah ouais. Charles
take advantage of inheritance. So I'm going to go into my Blueprints UI progress bar folder and go into the base class, WBP Globe progress bar. I'm going to get that open first and foremost. Now, I'm going to take a look at the assets folder and see what materials and material instances I have. I'm going to go into UI, into globes, and see what we've ghost and this drag it. If it depends, you'll net. But if we drag it down, knowledge, you will bright spot of it. And use for globe. Globe widget is within this parent base widget. Now I'm going to add another progress right here on overlay root and select that progress bar and right away I'm ghost. Then it fills the line. I'm definitely going to put it behind everything else and fills the widget, that horizontal and vertical alignment to fill. Then it fills the fine. I'm definitely going to put it behind everything else. Image. I definitely want that way down to 0 and it's blue. So I'm going to fix both of them. Erase the percent. I see it's going from left to right and it's blue. So I'm going to fix both of those. Problems now. I'm going to set fill color tint there to top. And I'm going to set the bar fill type. We see that it's going for background image. So let's give it a default. I'm going to select and search for mi_ghost. Give it a default. I'm going to select globe background image. So let's give it a default. I'm going to select and search for mi_matter. Like it should. We want it to look like that round material instance that it is. And it looks like I used background image. So I'm going to actually to draw as image to one of those ghost globes. And it looks good. And by the way, the reason we can do this is because if we go back to MI Health way, the reason we can do this is because if we go back to MI Health Globe, for example, and browse to the parent material, which is not a material instance, it's material domain widget request ghosting to want it to be in the back. And I'll step 1. Now, we have our ghosts, say, and perhaps it was made because, so I held away ghost one and change the fill image, right? So I'm going to set this to draw as image, and I used background image, that round material, and should. We want it to draw as image if we want this to look like it should. And remember, we need to draw as image if we want this to look like it should. We want it to look like that round material instance that it is. And it looks like I used background image, so I'm going to actually material and choose ghost health globe, right? And globe parent progress. And if I set, and you'll see that it's definitely going to put it. Now for the background image, I bring the alpha all the way down to 0. Right? So I'm going to take that tint color and bring the alpha all the way to being transparent. So I'm going to take that tint color and bring the alpha all the way down to 0. And as I raise the percent, I see it's going from left to right, and it's blue. So by dragging the saturation, the bar fill type to bottom, we see that globe, search for MI, globe really doesn't matter. Good. It isn't, looks like I use fill image, right? So I'm going to set this to draw as ghost, one of those ghost globes. back to not a material instance, and we double click that and it's requests glow. You want to take the tint down if you want it to be darker or something like that. And of course, you can also go back into progress bar ghost all the way up so that it's behind ghost globe, just trailing behind everything. And behind our progress bar globe, the ghost globe, and 5.9 variable that change I'm going to here, and our follows our regular globe whenever it changes. Right? So we need to think interpolate on a frame. And because we for both our help, so I'm okay. What I like to do is percent globe to progress bar percent. Every time we set that, it was going to want to that we can interpolate this. But I'd like a new variable, a new float. In other words, a ghost. I'm going to click add variable, and I'm going to call this, and I'm going to change it to a float. And every time we set our percent, I'm going to set our ghost percent target, but I may want to have a sort of delay, right? Maybe our regular globe changes and then we wait a second at press bar percent, but what we can't percent is called and call this globe percent is set. We can then set our ghost input. Let's click plus input, make it a float, and we'll call this percent. Globe percent set. We can call this, just reroute the node. There. Then once we set the custom node here, that way we can hard code it. I'm just going to promote it to a variable pile and give it a so for cat category, I'm going to call these ghost globe. So for category, I'm going to call delay is in it as well. Go ahead and refresh the node piling here. So my ghost delay is in it, ghost own. And I'm going to we'll give it a all compatible and call this of 0.5. We'll give it a 0.5 second delay. And I'm going to put these in a category of their own. So for category, I'm going to call these ghost globe properties. For category, I'm going to call these ghost globe properties. So my ghost delay is in it, and I'm going to set my ghost percent target to ghost globe properties as well. And compiling here, it looks like I get a compiler error. So I'm going to go ahead and refresh the node. There we go. We can get that sometimes. And I'm going to take my percent and set ghost globe percent to that. So every time we set the percent, then ghost globe percent will also be set. Let's actually organize this a little bit like so. There we go. That's looking better. Okay, so really all we're doing is every time we set the percent, we're setting the ghost percent target, but we're waiting 0.5 seconds before we do that. Now, another thing is what if we want our ghost globe material to be swapped out? Well, we can swap that out just like we've created parameters for the other brushes. We have an update globe image here, which really should be update globe brush, shouldn't it? I'm going to go ahead and rename that while I'm noticing that because everything else is consistent. So this should be update globe brush. But we can have an update ghost globe image. We can have a ghost add and call this ghost progress bar. I'm going to add a new variable under globe bar fill image. So our fill image, and I'm just going to call it ghost progress bar brush. And this is going to be a slate brush. And our progress bar fill image is actually going to be progress. Bar fill brush. I'm going to rename that too. And this can go into ghost globe properties. Let's give it that category. And we'll compile and give it a default value for the brush image. And I'm going to give it mi ghost health globe. Compile. All that. And we'll make a function just like update globe brush, we'll have an update ghost globe brush. So I'm going to make a new function, update ghost globe brush. A slate brush with 0 opacity, that'll be for the background image. We'll use the ghost progress bar fill brush, and we'll use the ghost progress bar globe and set style. So what I'm going to do is just copy all this and go into bar globe and version progress bar ghost. So we'll switch that out, and instead of progress bar fill brush, we're going to use ghost progress bar brush. And of course, this is called ghost progress bar brush, and the other one is progress bar fill brush. Just to be consistent, I'm going to call the other one progress bar brush. Just so we have consistent names there. And now we have update ghost globe brush, which we should call right here. With all our other update functions, which, by the way, we could collapse all these to a single function if we wanted to do that. But anyway, we have ghost percent set, and all this does is set ghost percent target, but we're going to want to interpolate our ghost percent to this every frame with some kind of interp speed. So we have a function to set our progress bar percent, right? And what we should do is every frame set our ghost progress bar percent. So let's look at set progress bar percent. All it does is set percent, right? And also call our new custom event globe percent set, but we're going to want to set ghost progress bar percent function. Let's add that function. And we're going to say set ghost progress, and we're going to say progress bar percent function. Let's add that function. And we're going to say set ghost progress bar percent. And this will just call set percent on the ghost progress bar. Let's get our progress bar ghost out. Call set percent. And just like set progress bar percent, which takes in a float, we can add a float input here. So we'll add a new input of type float called percent. I'm going to compile right away. Okay. And then we'll use percent to set the percent for our ghost progress bar. Now we want to interpolate. So let's just use event tick. And what we have is we have our ghost progress globe. Let's get that out. Progress bar ghost. And what we're going to do is interpolate. I'd like to use finterp2, which interpolates floats. So we need to know the current value of the ghost progress bar percent. If we drag off of the ghost progress bar and type percent, we can get percent, and we can hook that in. That's the current value. Value every frame, hold, and that's going to be for the target there. Now we have delta time because we're using event tick, so we're going to hook it in delta time, and now we need an interp, a value of 1. In fact, I'm going to speed, I can go ahead and put this into the category of ghost globe properties, compile and set it to a default value of 1, which it is. And so after we've interpolated here, what we can do is we can set our ghost globe percent. So we can get that new function, set ghost progress bar percent. Here, progress bar, and child classes in the globe. So we need to right click on event tick and WBP health globe and add a call to parent function. So if you, and we'll do the same thing for mana nodes. And that way the child get that interpolation going. So let's go back to tick, and that's very important so that we get that interpolation going. Even though the health globe and the ghost globe don't start off at the same values, that ghost globe is interpolating down to those values. And of course, our ghost delay determines how long it takes before that happens. We can set that to a value of 1, so we can get a nice 1 second delay. And I don't see any transparency with my globe, and that's because we're actually setting the brush in update globe, because we're actually setting any transparency with my globe, and that's because we're actually seeking likes. Before that happens, we can set that to a value of 1, so we can get a nice 1 second delay. And I don't see any transparency with my globe, and that's because we're actually setting the brush in update globe brush. We're updating with progress bar brush, and that has its own tint here. So if we really wanted, say, 0.9 on the alpha for that, we'd have to set that here for progress bar brush. So now we should be able to see a little bit of transparency, and just behind the globe we can see the trailing ghost globe. It's really apparent in the globe we can see a little bit of transparency, and just behind the globe we can see the trailing ghost globe. It's really apparent. It's not a value that I'd want, but much smaller, like 0.3. Really apparent if we set this alpha to something much smaller, like 0.3. It's not a value that I'd want, but you can really see that the ghost globe is trailing behind in that case. I'm going to leave it at about 0.9 though. So that's the alpha on the tint for the progress bar brush, which we're setting here in update globe brush. And of course, we're doing that in the event pre-construct. Of course, we're doing that in the event pre-construct. Okay, so it's looking in or the progress in that case. Really see three parent if we globe we can see for progress. Really wanted progress bar globe or actually see any nice before that happens. Ghost globe and the ghost and press play. Very important. See the child should hook up from man on this part. So we need to blueprint tick call this. We can hook globe to interp. Be experimented with. I'm just gonna. We need an because we're using event tick, so we're gonna hook in delta time, and now we need an interp speed. Now this can be experiment. Experimented with. I'm just going to try interp speed, event tick. So we're going to hook in delta time, and now we need an interp speed. Now this can be experimented with. I'm just going to try a value of 1. In fact, I'm going to make this a parameter. You can go ahead and put this into the category of ghost globe properties, compile, and set it to a default value of 1, which it is. And so after we've interpolated percent. Set ghost value from before that last globe on the nodes parent version. Let's go back and press play, and we can see that even though the health globe and the ghost globe don't start off, we can see that even though the health globe and press play, and we can see that relations will get their parent version of tick, and make sure to hook up all the nodes, and that way the child classes will get their parent version of tick, and that's very important so that we get that interpolation going. So let's go back and press play, and we can see that even though the health globe and the ghost globe don't start off at the same values, that ghost globe is interpolating down to those values. And of course, our ghost delay determines how long it takes before that happens. We can set that delay. And I don't see any transparency with my globe delay. And I don't see any transparency with my globe. And that's because we're actually setting the brush in update globe brush. We're updating with progress bar brush, and that has its own tint here. So if we really wanted, say, 0.9 on the alpha, for that, we'd have to set that here for progress, a little bit of transparency, and just behind the globe we can see the trailing ghost globe. It's really apparent the globe, we can see the trailing ghost globe. It's really apparent the globe, we can see the trailing ghost globe. It's really apparent if we set this alpha to something much smaller, like 0.3. It's not a value that I'd want, but you can really see that the ghost globe is trailing behind. In that case, I'm going to leave it at about 0.9 though. So that's the alpha on the tint for the progress bar brush, which we're setting here in update globe brush. And of course, we're doing that in the event pre-construct. Okay, so it's looking good except for the fact that they don't start off at the same values, right? Because they have different default values. It's really apparent when we step into the fire. And I'd like this fire to take a little bit more each period so we can test this ghost globe a little better. So I'm going to go to my GE fire area down to its modifier and change this to -5. So every second we're taking 5 away from the health. And now we can really see that. that ghost globe trailing behind. So the problem is the initial values, right? And the easiest thing to do is just set them both to full from the start. Perhaps here in event pre-construct, we can just set the progress bars both to full. We can get our progress bar ghost, we can get our progress bar globe, we can call set percent and just pass in 1 and then just initialize both of these to have a value of 1 from the start. And then they just start off. But there's a problem. We can see the ghost globe sort of interpolating down to what value? Well, that value is the actual value of the attribute, right? Because look at this. We show debug. Health is 50, mana is 10. And you can see the ghost globe. You can barely see it, but it's down to halfway on the red and about 1/5 of the way on the blue. So that would mean we'd need to set that target value also to 1. Under ghost globe properties, we have the ghost percent target. We'd have to set that also to 1. So we're setting everything to a full globe from the start. But of course, the problem then becomes, well, we're setting them to the values that are not accurate, right? We're not setting them to the values they should be, and that becomes apparent when we step into the fire. We go from a full globe to 5 less than what our real health was. So just setting everything to a full progress bar from the start isn't really going to cut it. What we need to do is we need to know if this is our first time setting our globe percent. In other words, is this the initial set of our regular globe? So we can go to set progress bar percent, and an easy way is to just have a Boolean value that we can set once we've set this for the first time. So we can have a variable, it can be a bool, and we can say globe initialized. We can compile and make sure that its default value is false, and then in set progress bar percent, we can set it to true. True. But we can check to see if it hasn't been set yet. So we can make a branch. We can say if globe initialized, and if it's false, well, this is the first time. So in that case, we are setting globe initialized to true. And if it's true, well, we just do what we were already doing. But in the false case, we want to not call globe percent set. We want to set the progress bar globe percent. So we do want to do this. But we also want to set the ghost percent to the same amount. So we're going to take our ghost progress bar ghost, and set the percent for this as well. And what's the percent? Well, we're going to set it to this percent value here. And the interp target for the ghost percent target, must also be set to the same value. So that it's not attempting to interp to any other value. Now, this isn't going to work exactly because there's one detail we have to remember. Percent could be 0. If we go into Health Globe, we'll see that when we bind to these callbacks here, we're calling set progress bar percent the very first time our health changes, and either the health or max health, one of these two, has not been set yet. So either health is still 0 when we set our max health, or max health is still 0 when we set our health. Either way, the result is going to be 0. And the very first time we set our progress bar percent, it's going to be 0. And that means that if our globe has not been initialized yet, we'll get this false case, and then we'll initialize both the ghost and progress bar at the same amount, but that's going to be 0. And then immediately after, our progress bar will be set to the correct value, as both health and max health will have been set, but our ghost progress bar will still be 0. So what we can easily do to fix that is we can check percent to see if it's greater than 0. If it's greater than 0 and globe initialized is false, now we'll consider this the correct time to initialize the ghost progress bar to the regular progress bar amount for its percent. So in the false case here, we'll do another check, and only if this percent is not 0 anymore, then we'll go ahead and initialize these. So we can test this out. And I'm going to take my progress bar brush and for its default value, set its tint way down so we can really see what's going on. And I can press play and I can see that these values are correct. As I increase my mana, there we have our ghost globe following behind. So that's working. I'll go ahead and set my tint back to 0.9. And this is a function, so I can promote this percent to a local variable. I'm just going to call it progress percent. We'll promote that, set it, and then we can use it in place of all this, set it as percent to a local variable. I'm just going to call it promote this percent to a local variable. I'm just going to call it progress percent. We'll promote that, set it. And then we can use it in place of all this green spaghetti here. So I'm going to take progress percent here, replace that. We'll replace it here. I'm just going to use Control D to duplicate. And we'll go ahead and get rid of these green wires. And we can just clean this up a little bit. All right, and we'll go ahead and just tidy these up a little so that our globes are starting off at the correct amount. And my ghost delay is quite short. If we do get that delay, we do to 1 second, okay, unless we hard code a value. Yeah, so it doesn't want to use this variable for the delay. That's fine. We can always just come in here and change it. So I'm going to remove ghost delay. Okay, so that was kind of a lot of work just to get a pretty simple effect, but the effect is pretty nice. You know, it does make a parameter. So we could go into our WBP health globe and make sure that the ghost globe brush here, it's called ghost progress bar brush, is set to the one we want, and it's ghost health globe for the WBP health globe, and for the mana globe, we can set that to the one we want here as well by going to ghost globe properties, getting our ghost progress brush, and making sure this one is ghost mana globe, and that way it's a little bit more